Yep. Okay. Yeah. So Yefim apologizes for having a bad connection today. So I'll be presenting his name. It's a pleasure to introduce today's speaker. It's Professor Marius Usher, is cognitive neuroscientist from Tel Aviv University. Marius is a professor of psychology in both the School of Psychological Sciences and School of Neuroscience, where he works in the interface of cognitive psychology, neuroscience, and philosophy of mind. His research focuses on the dynamics of decision making. He's developed many influential evidence accumulation models of choice and published widely psychology and neuroscience with many papers, including Nature, Science, Psychological Review, other fantastic outlets. And his work is widely cited in the decision making literature. So we're very happy to have him with us today. As usual, we will have around 50 minutes for the talk and then some time for questions. And for those of you who would like to stay a little bit after, that's also fine. Marius, thank you for joining us. Floor is yours now.
Thanks, Ori. Let me just a second. I turn off this air condition. Okay, so I will speak about compensatory versus heuristics models of multi-attribute decisions. And let me start with an example of a multi-attribute decision. For example, I want to choose between two job candidates. And the two job candidates, say A and B, are described by values on a number of dimensions or attributes. Now, the normative theory to make such a decision is to provide, to assign some importance weights to each of the attributes and then calculate a weighted average for each alternative and choose the one which has the highest weighted average. Now, there is a debate whether people are actually able to do such a to apply such a decision. And one of the quite prominent approaches today follows the bounded rationality theory, which argues that in fact people don't have the capacity to carry out such rational, to apply such rational decisions because the computation necessary for this is too difficult, and people therefore resort to heuristics, which basically ignore a big part of the information. One of the heuristics I will focus on is what is often called take the best. In this case, take the best will say, let's look only at the most important attribute, and then we choose B over A because 6 is larger than 3. And that will be, in this case, a mistake because the weighted average is larger for A. So there are a number of such simplified heuristics. Take the best is one of them. Another one will be frequent winner. I will look at the alternatives and count wins. So here is a win for B, that's a win for A, another win for A, and I go by the number of wins. One approach that has been developed sees intuition in decision making as heuristic decision making. According to this, in complex decisions, people use heuristics. That's the approach that has been endorsed by Gigerenzer Group, and it follows some work by Tversky, earlier work by Tversky. An important motivation for this approach was what was often called the EIP calculus. EIP is an abbreviation for elementary information processing. So in this paper, Payne and colleagues have examined different decision strategies by how many EIP they require. An EIP, an example of EIP is read the value in working memory, add numbers, multiply, subtract. So according to this, in order to compute a weighted average, there are a lot of EIPs that one has to go through, while just relying on take the best, there are much less EIP, and therefore it has been argued that the heuristic approach is EIP economic, and therefore people will typically rely on it, especially under time constraints. And that links with a dual framework theory, which thinks of system one, the intuitive system, which is fast automatic, as being based on heuristics, and system two, the reflective rule-based controlled, which is a system that could in principle carry out weighted average, but people will not do it unless they have a lot of time and they will use pen and paper or computers. I want to focus on an alternative approach. And according to this alternative approach, I would like to challenge the association that bounded rationality makes between intuition and heuristics. And what I want to suggest is there might be a different type of intuition, which I call holistic intuition, which can be applied in complex decision making. And just to give a highlight of the idea, and I will later return to this, I want to mention this model that has been presented by Andreas Glockner, the parallel constraint satisfaction model, according to which, in fact, a neural network can compute a weighted average in parallel. There is no need to go through sequential steps. So perhaps all the idea of this calculus, EIP calculus, is a bit outdated once we take into consideration parallel processing. So I will start with some experimental studies that we did in our lab a few years ago, and those are the students who carry out that older project. So we had participants making decisions between job candidates, and each trial appears something like that. You see two job candidates. There are 3, 4, or 5 attributes. This is an example with 4 attributes. We also provide, we assign, we ascribe weights. We tell people that you make a decision between candidates, but the job has told you what weight you should give to each attribute. So that's the most important attribute, should have a weight of 4, 3, 2, and 1. You have this matrix of values. You can make a decision. We tell people you have only 4 or 5 seconds, depending on the number of attributes. For 3, we gave 3 seconds. Each additional attribute we increased by 1 second. So you have, let's say, 3 seconds to look at this and decide whether to choose A or B. You don't have time to calculate, try to estimate. That is instruction. Okay, so we have a time limit. And here are some results. Those are 200 trials where people carry out the task with 3 attributes. Then they do another 200 trials with 4 attributes and another 200 trials with 5 attributes. We also provide feedback, whether they make the correct decision or not. And what we see, that's accuracy for sub-blocks of 50 trials. And what we see is that from the beginning, people are quite stable. There is not much learning in this task. They are quite able to carry out this task at a performance that reaches about 90% with 3 attributes. With 5, it goes down to 85%. And the solid line is average performance of participants. The open circles corresponds to what the maximum performance that one could do if following a take the best strategy without any error, right? So for example, in this case, if I choose B over A, I will choose according to take the best, and I will assume there are no mistakes in applying the take the best strategy. If a person will rely on take the best without errors, they could achieve still a good performance. But what we see is that the actual performance of participants is higher than take the best could achieve.
Marius,
Another important thing is that the mean RT, we gave a 3 seconds, let's say, deadline, but people responded in average about 1.5 seconds. That includes looking and pressing the button. And in fact, we found a negative correlation between RT and accuracy after controlling for difficulty within each subject. So what
Marius,
it
can I
is,
ask a clarification question?
yes,
So the difficulty is the number of attributes?
no. For each difficulty, well, difficulty, I would say, for a given number of attributes, we consider difficulty by the difference in
The
weighted
difference.
average. There are,
Right.
because those numbers are randomized. They are randomized by the computer. So sometimes you might get large numbers on the left and small numbers on the right. I consider this as difficulty. So if a difficulty, I consider the difference in weighted average.
And
Okay?
it's a block design, so they do 3 attributes first, 200 tries, and then it's a block
Yes.
design, or is it a mixed design?
No, it's blocked. So
Okay.
we do 200 trials of that, and then they go a bit more difficult, 4 attributes, 5 attributes. And this
Thank you.
analysis is done within each condition. So what you find is that when a person, let's say, takes some time longer, 2.5 seconds, but in average, they will not be better than the way they respond in 1 second, because we obtain this negative correlation. Okay, so now what we can do in this task, we can do a classification of decision strategy and decide subject by subject if they relied either on what we call weighted additive utility, WAD would be weighted additive utility, or weighted average. I use this name interchangeably because in different papers we used one or the other, so please excuse me, you will see both. Or alternatively, whether they rely on take the best, which has there is a rationale to use take the best because after all, the first attribute is the most important. So if you rely on take the best, you will still be right in about 80% of the trials. So some people might do this, and we test this. And third, we looked at one more heuristics, which is equal weight heuristic. Just choose by the average, not weighted average. And we call it equal weight takes the best because if there is a tie on the average, then choose by the first attribute. Okay, so here are the results of the classification. 60% of our participants appear to rely on weighted average. Now, well, let's say it more minimally. They make their decision consistent with a weighted average mechanism. Now, there are about 30% of participants which appear to make choices consistent with take the best, and few, less than 10%, which seem to apply a equal weight heuristic. So that is a study we had a few years ago. And more recently, with Gal, we started to look at the following questions. Could it be that some of the participants that we thought they were relying on weighted average or weighted additive utility, they were instead looking or relying on a heuristic which mimics it. And here is a heuristic which we thought might mimic weighted average. Let's say that in every decision, I choose a single attribute, but I choose it probabilistically with a probability that corresponds to the normalized weights. So if this 4, 3, 2, 1, let's say I will choose this as 40%, 30%, 20%. So I choose in each trial randomly, but with a probability, one attribute, and I just look at the difference between those. I choose a larger one. That will still be a heuristic, and it can mimic the decision of weighted average. With weighted average, we assume also that we have some additional noise because the weighted average is estimated with some, let's say, Gaussian independent noise. And if we take the two models, the weighted average with independent noise and the probabilistic single probabilistic attribute model, we call it SPA, and we make choices based on all the problems that people see in the experiment, and then we apply logistic regression to determine the weights. We obtain very similar weights. Blue and red corresponds to the weights for the heuristic SPA compared to the real weighted average. So you can see that just looking at choices, it might be difficult to know whether the person actually chooses according to a weighted average, a compensatory model, or whether they choose based on a single attribute which is sampled probabilistically. However, we thought that it will be possible to distinguish those two models based on decision time. So here is an interesting decision variable for our problems, which we call decision polarization. Consider these two. Here is a high polarization trial, A and B, and here is a low polarization trial. And I have here attribute 1 and 2, which I describe on those two dimensions. So for the high polarization trial, I have these two choices, alternatives, which are very polarized. They are more or less of the same weighted average. So A and B in the high polarization have a difference of weighted average of 0.3. And in the low polarization, they also have a difference of 0.3. So, however, the difference is that for the red alternatives, there is a large value on one and a very low on the other, while for the low polarization, they are very similar. Now, why these variables, decision polarization, is interesting for decision time? Remember that according to the heuristics that I described, I randomly choose one attribute. Let's say I choose attribute 1, and then I have a very easy decision to make, 8 against 2. I am very fast. If I choose the other one, I also have a very easy decision to make, 2 against 8, very easy. But if so for low polarization, if I choose attribute 1, I have a difficult decision. If I choose attribute 2, also I have a difficult decision. So the high polarization trials will give me fast decisions according to the SPA, but according to weighted average, I have to first generate the weighted average, and then I make a decision based on weighted average, and then it shouldn't matter. So yes?
It's unclear to me why is 8 larger than 2 is much more easy than 6 larger than 4.
Okay,
Both
so
are very
maybe
simple,
you
right?
heard about those experiments that you ask people to make decisions between digits or numbers. And the very typical result is that the larger the difference, the faster people are to make that decision. That was, I think, the French group. Yes.
We didn't study introduction
Dehaene.
to was not a psychologist.
Yeah.
But let me ask just another clarification question. But the accuracy rate will be much lower with your heuristic, right? It's gonna be close to 50%.
Yes, you are right. So if I am gonna use this heuristic single probabilistic attribute, my performance will be lower than take the best. So because it takes the best, I mean, if I'm using a single attribute, I should best use the most important one. And if I use the attribute probabilistically, the performance will be lower than take the best. So it will be around here. So that's a very good observation. So what we did, in fact, in this paper, we designed an improvement to this SPA, which is supposed to help it improve its performance. And I will not speak about it here because it will not, I wanted to focus on some other more interesting things, but I will say what was the idea. So let's say if we find on the most important attribute that the difference is smaller than delta, let's say 2, right? Then we consider this to be a tie, and then we look at the next one. So we have a series of such heuristic models. We call it SPAD, where D is a parameter for the delta, which can improve performance and bring it a bit higher, but definitely it will not be higher than take the best. So
But you
now
can
with
also do the same thing with the take the best, right? So you can modify take the best.
You can modify take the best too and make it, well, if you modify take the best and you add, it will not improve much because then you go to the less important attributes. And looking at less important attributes, yeah, it will improve a bit, but not much. But what I want to say now, with the weighted average, performance is determined by the noise. And the noise is a free variable. So by playing with noise, which is a free variable, one can obtain any performance that one, every possible performance. But these models, the heuristic models, are bounded to a maximal performance. They cannot do better than something. Okay? So it is possible that a participant in the experiment might have I mean, that is average performance. So some people will be at 90%, and we can exclude that any heuristic is being used. But there will be participants who are at about 85%, and that will be consistent with one of the heuristics model. Okay, so therefore, we look at response time. Okay, so let me consider response time. So here is an example. Well, I will explain you what these graphs are. I consider a diffusion model, so probably most of you are familiar with drift diffusion model. And in the drift diffusion model, I assume the drift is given either by the weighted average. If I use a weighted average model, I compute the weighted average, and the weighted average with noise is what is driving the evidence for the choice. And in this case, high or low polarization don't reach the decision boundary at the same time. However, if I use the single probabilistic attribute, what you find is that high polarization trials, they are driven by a large difference in attributes, so they reach very fast. Low polarization trials, they are much slower. The slope of the diffusion is much slower. So, and again, if you do, that was an illustration for that very simple case that I showed here. But if you take like random problems that are randomly generated, what you find is that the distribution, so for the SPA, you have very different distribution for low polarization and high polarization. For weighted average model, the distribution are very overlapping. And if I compute, those are all the problems we have in our data, and we apply this model to generate response times. So for SPA, you found a negative correlation between polarization and RT. That is a Pearson correlation. And for weighted average model, it's totally flat. The correlation is virtually zero. So we went to look at a data in an experiment. So this is an experiment with, say, 54 participants. People have done multi-attribute decisions with 3, 4, and 5 attributes. There were prescribed weights. For 3, they were 3 to 1. For 4, there was 4, 3 to 1. For 5, it was 5, 3 to 4, 3 to 1. The decision was constrained by time limits: 3 for 3 attributes, 4 for 4 attributes, 5 for 5 attributes, and it was blocked as before. We have 450 trials in total, 150 for each block. And okay, so here is a strategy classification. Again, we obtain that in our study, about 70%, 63 to 70% of the participants were classified as doing choices consistent with weighted average, and again, under the time constraints for 3, 4, and 5 attributes respectively. And if we for each group of participants, those classified as weighted average take the best, we compute the decision weights by logistic regression. We find what would be expected. For example, for take the best classified participants, you obtain that attribute 1 is overweighted, so people give more weight than they should, and attribute 2 and 3 are underweighted. But as you see, for people classified as weighted average, they have decision weights that are very close to the normative prescribed values: 3, 4, and 5 attributes. Okay, so now let's focus on the people that were classified as weighted average. For nearly half of them, 16 out of 37, the SPA model, the single probabilistic attribute model, can be excluded based on accuracy alone. So many of those people have a performance accuracy that is can exclude the single probabilistic attribute. But there is another half of the participants, about 21 out of 37, for whom we turn to RT, in particular to stimulus polarization, to see whether it is consistent with what I spoke before, the negative correlation between polarization and RT. So here is a representative participant. When what you see, there is totally flat distribution of RT across polarizations. Pearson correlation is very close to zero. And across the group of participants that were classified as weighted average, the Pearson correlation is very close to zero, not significant. And in particular, we carried Bayesian analysis, and we found a Bayes factor in favor of the null correlation, which is quite large, 8, 6, 5, in favor of the null hypothesis. So, okay, so here is some complementary analysis that shows exactly the same thing. We try to predict response time in a regression model by using the weighted average difference. So I take the weighted average difference between the two options, and then that's one model that is using only this. The second model is also adding polarization as an additional regressor. And we use BIC, which gives a penalty for degrees of freedom. And what we find is that the model without polarization is preferred in terms of BIC. So all these results we replicated in a second experiment. So this seems to support, we think, that it is possible to generate a weighted average based decision using a holistic computation of the weighted average rather than what was usually thought to require a heuristic type choice. And I mentioned already this model by Andreas Glockner. It's called PCS, Parallel Constraint Satisfaction Model. But I think the problem with applying it to the data that we have is that in order to have this model working, the values need to be encoded into these weights. And it's not very easy to think how would I make this very fast encoding if I see a matrix of values and immediately the matrix is transformed into weights without any learning. So here is another idea that is more, I think, easy to understand for us, which is based on holistic extraction of summary statistics. So you probably know if you see a large set of, let's say, circles, people can look at this for half a second or less, and then decide whether this probe is smaller or larger than the average. And the idea is that we don't need to encode each element and we don't need to do a sequential processing, but it's possible by some kind of parallel process to extract summary statistics like average or standard deviation and to make a decision. And the idea that I would like to propose that such summary statistics can be in fact applied to decisions of, well, of this type, right? I can look at these numbers and I can generate an estimation of what would be the weighted average with a bit of practice, knowing that the first attribute is the more important, this a bit less, and so on. Okay. So far, what I was saying is that people are able to deploy such holistic mechanism of decisions, they are compensatory, quite fast. But still, somebody might be happy enough to apply heuristic like take the best. I mean, it is providing us with a bit less good performance, but it's not a disaster. For the task that I just showed, the performance will be still around 80%. So one might say, not a big problem. But I want to explain a bit why, in fact, using those heuristics lead to violations of rationality. And this is something that probably some of you or many of you know. One of the most central axioms of rationality developed by von Neumann and Morgenstern is transitivity. According to transitivity, if I prefer A over B and I prefer B over C, I should also prefer A over C. That is a measure of being consistent with my own choices. And violations of transitivity, of preference transitivity, are inconsistent with rationality. And if you need a motivation for that, you can think that such inconsistent preferences can cause you to become a money pump. So that is an illustration of a money pump. A person who prefers a chocolate for the $1 prefers a lollipop for the chocolate and prefers a dollar for the lollipop. So such a person will buy the chocolate and will pay $1.1, then will trade the chocolate with the lollipop, then will sell a lollipop for the $1 and ends up in the same location but with losing 10 pennies. And then you go again, and each such loop of inconsistent preferences, you are losing money. Now, all heuristics of the type I showed take the best, and I might illustrate you another heuristic, which is here. Another heuristic other than take the best is frequent winner. Frequent winners say choose the option which has more wins. So B has a win here, A has here. So in this case, A should be chosen by frequent winner. Okay, so all these heuristics which don't integrate across all attributes, they are in danger of generating violations of transitivity. And what I want to, if I have another 10 minutes, yes?
Yes, yes. You have more than 10 minutes.
Okay, good. So what I want in the last 10 minutes is to show that indeed, if we make multi-attribute decisions, often we find participants who violate transitivity, and that was shown first by Amos Tversky. I think it was in 1969. There was a debate about those violations of transitivity between, I think, the main researcher who argued that some of this conclusion of violation of transitivity were wrong was Michael Regenwetter. But in recent work, which I have done with Konstantinos Tsetsos, we have demonstrated those violations of transitivity quite consistently. And in fact, this is a new paper which Michael Regenwetter joined us, and he was satisfied that indeed we do find such violations of transitivity. But the interesting part that I want to focus on is not just that people sometimes violate transitivity, but that those violations of transitivities are driven by what we call within attribute processing. So I want to distinguish, okay, maybe let me explain the experiment that we ran. So we ask people to make a choice between athletes for Olympic Games. And we have two conditions which are manipulated within subjects. Okay, so let me first explain the task. People will be told you need to help to select an athlete who will represent the country at the next Olympics in gymnastics. Only one athlete can represent the country. Therefore, the Olympic Committee must choose the best one. You will be asked to choose each time a gymnast preferred from two based on their scores in a competition on different devices. A series of early competition results will appear each time the scores of two gymnasts on three different devices, pommel horse, rings, and parallel bars. The three devices are equally important. Okay, so here is, and I said we have two conditions. In one, they were done in different sessions. In first session, the sessions were counterbalanced. But let's say a given participant will come to the first session and will see the choices in this format. Here are the two athletes, 1 and 2, and those are the three devices. And we have these bars, and the person will look and will make a decision, 1 or 2, right? There are many such choices, definitely. And in the other session, he will again make choices between the two athletes, but now you see the coloring is different and the bars are horizontal rather than vertical. Now, what is the reason for that difference? What we wanted to do is to highlight to people either to make comparisons between values of within an attribute. So in this case, we thought that grouping by color and the fact that it's easy to compare those two bars will make it easy for people to pay attention to this difference and say, okay, here I have two differences in favor of B. So if I use frequent winner, I will choose in this case B or option 2. And in the other condition, the color enhances processing within an alternative. And it's much more difficult to compare those bars when they are aligned collinearly. So therefore, we expect that people will generate an evaluation, an overall evaluation for the value of each alternative. So that is what we think about a summary statistic. You read these bars and you get a feeling of the average value. And the same you would do here. And then people were told that the bars might be displayed vertically or horizontally depending on the format that the company that collected the data uses. There also a difference between the companies in the way the data is colored. So they are not too confused why this changes. Though there are two different sessions. And here are our results. And what I show here is violations of transitivity. And what you can see, those are two measures for violation. That's are two experiments. Experiment 2, experiment 3 is a replication of experiment 2. And those are two measures of violation of transitivity. One is looking at with stochastic transitivity violation. The other is a more stringent measure called triangle inequality. And by both measures, you see that in the session, in that type of session where the attention was focused on comparing attributes, people make more violations of transitivity than when the information was presented in this way. So there is a case to argue that if we look at each alternative and we generate a value for it without starting to compare it with the others, we might have an advantage in terms of, let's say, rationality principles, in this case, transitivity. So let me end with some conclusions. What I was trying to suggest here is that human participants are able to carry out multi-attribute decisions in a fast and normative way, or quite normative. We can rule out heuristics based on a single attribute, on attribute-wise comparisons, and support holistic decision mechanisms. And we suggest that they might be mediated by extraction, parallel extraction of summary statistics, in this case, averaging or weighted averaging. I have tried to argue there are benefits to holistic compared to heuristic decisions, for example, transitivity. And we showed that violation of transitivity of preference are supported by within attribute heuristics, and they are reduced with holistic within alternative decisions. So I will leave with two questions, which I think we are still thinking, considering, struggling with. One thing that we observed in most of our experiments is that there is, for exactly the same task, the same condition, a lot of individual variability. I spoke about 60% or 70% of participants who appear to deploy holistic compensatory strategy, but this leaves us with the question of what determines those individual differences in holistic versus what I would call it dimensional or attribute-based processing. There are a few things we are trying, but I don't have yet an answer. And maybe to end up with something practical. So let's say I now go to make a decision, an important decision, choosing an apartment. That's the type of difficult decision that people are usually agonizing about. What should I do? I mean, one option, I saw a few apartments, I start comparing how many rooms, how is a terrace, which has a larger terrace, which is closer to the beach, and I start making those comparisons, and then I end up with a heuristic. I use take the best frequent winner because it's difficult to integrate the differences across the different dimensions. But another option would be just go inside the apartment and get a feeling of it, give it a value. Say on a scale of 0 to 10, I think this is apartment, I give it a value of 8. Then forget about it, go to see the other apartment, get a feeling of it. You might say try not to compare. On a scale of 0 to 10, I give it a value of 6. Okay, so now it choose based on this. I'm not able to tell you yet that that's how you should make your decision. I think it's still an issue for us to determine or to do more studies, and it will be a difficult question. What is a decision criterion that we can compare for such decisions? But I think we can stop here, and if there are questions, we can discuss.
Great, thank you very much, Marius.
Thanks, yeah.
Okay, so we have a question from Kinneret.
Thank you, Mark. Very, very interesting. And I would like to ask you, you talked about individual differences, but maybe it's more of a state kind of thing, that there are some situations in which people learn to follow holistic processing and other situations in which people, I don't know, learn to follow dimensional processing. And then the question would be first, are there cases in which dimensional processing is beneficial, is better? Because you showed us that holistic is better in terms of transitivity, right?
Yes.
So, but
Well, I mean, yeah, definitely. I think that was one of the things that Geger and the group has always argued, that relying on heuristics is beneficial in particular situations. So, for example, what they consider the situations that will favor heuristic is time pressure. But I think I showed here that time pressure is not really a good distinction, because people had a time pressure, they had 3 seconds, 4 seconds, 5 seconds, and they didn't use the full 3 seconds. Once you start to make this estimation, you learn to do it fast. So you can probably do those quite fast because you don't have to do sequential processing, symbolic sequential processing. But another criterion that will favor heuristics is that the weights of the attributes are very different from each other.
exactly.
So if one has, we used weights of 3 to 1 or 4, 3 to 1. But if you use weights like 8 to 1, then, I mean, the difference between take the best and weighted average will be negligible. So yes, there will be such cases in which relying on a heuristic will be very beneficial. But I think that there are many cases in life where we are not in such easy cases. So I call those very easy decisions. The most important attribute can determine everything. There are many cases where there are more things to consider. And in those cases, I think that, I mean, at least in these cases, because we had a prescribed value, using take the best was still losing us, like something like 10% of the performance. So if you can do better, why not? Now, the other thing you said is that maybe um, one can learn this depending on some previous training or something.
Or in other words, in your case, it might be that people over time will actually learn to use more holistic or to prefer the holistic approach. Right?
Yeah, but we see what we saw here is when we looked at performance as function of time in blocks of 50, it seems that there is not much learning here. I mean, maybe there is a bit of learning. Well, um, I think you just get used to the task, but you cannot learn because each problem is a very new problem. You cannot learn the weights, right? Each time the weights should be different. The values that you see in each problem are not the same. So there is no learning that will give you the values that will give you a correct answer. But maybe you can develop some weights for the most important attributes, the second. Yes, maybe something like that. But I mean, we see that people are quite good from the beginning. It doesn't seem to require a lot of learning in our experience. Now, it's possible that I mean, that's something that we're still looking into. For example, one of the things I would like is to do a manipulation that will, let's say, induce holistic processing. So give people a task that will require holistic processing and then see if it affects the amount of compensatory strategy. That's, I think, an idea which I like.
Thanks. We can discuss later. I see that
Yeah.
Patricia also have a question.
Yes.
Yes, hi. Thank you so much for your presentation. I just wanted to make a comment maybe together with Joanna Sokołowska back when I was doing my PhD. We did a lot of work, very related work. And what we found is that we looked at multi-attribute decision in different type of contexts. And what we found is that even if you apply those simple strategies, we looked at lexicographic and then Simon's bounded rationality type of strategy and the weighted attribute. And so we found that when the decision is more difficult, so when the context is health-related decision as compared to, choosing perfumes or other products, those who apply simple leg strategies are almost as equally transitive in their preferences as those who apply those multi-attribute, the weighted models. So compensatory models versus non-compensatory models were participants were equally transitive across studies with like difficult decisions. So that's something.
So, yeah, maybe can you send me the
I will.
article? I'd be happy to read. And
Yes,
you can
I'll
see
send
our
you.
article because
Yeah,
our article will come up in Psych Review, I think, this year.
yeah.
But I will be happy to read the one, your study, and think
Yes.
about it.
Thank you. Yeah, I'll share one article. The other one, which is like purely theoretical, we're still working on it. It's taking us 8 years, but
Okay, so if
hopefully
you
one.
send to Ori and he will
Yes.
email it to me.
Yeah, for sure. Thank you so much.
Okay, thanks.
Okay, any more questions? Okay, so I have a question actually. Marius, can you clarify when you made a comparison between that mimicking heuristic and the weighted average one? Is it a fixed heuristic? So each person must only use the single, for example, D. You said the SBA or something, right? SBAD. You must always use the same D, or is it possible that in some trials people view a difference of one as the tie, but in others difference of four is a tie? Is it something
I
you
mean,
consider?
I didn't examine such a mixture of for this parameter.
Right.
But
So if you do a mixture, my guess is that if you do a mixture, you also wouldn't get that negative correlation with response times. I think
I think you will get it. But
you will get
the
it.
other thing is that if you, well, in fact, um, in most of the people that our participants, the best performance was obtained by D equal 3. So a D which is too small doesn't make much difference. But if you make it too large, it's not good either, because remember, the first attribute is the most important. So when let's say you make D equal 6 or 7, that means that very few trials will be decided by the first attribute. And then you make the decision based on less important attributes. So there is an optimum value of D which reach you a performance which is close to the data. If you use a D equal 1 or 0 or 2, performance is so low that you can exclude most of the participants. Most participants are at a performance larger than that. But even if you, just theoretically, if you use a mixture of D, for every value of D, you have a negative correlation. The negative correlation between decision polarization and RT takes place for every D value. Therefore, putting them together, it will still be negative. But we can talk about that.
Yeah, maybe you can talk about it. But okay, so this is maybe more generally. When you say that a participant is best described by a specific
I mean,
strategy.
maybe what you might have in mind is that the person doesn't need to use take the best in all trials. Maybe in one trial they use take the best, and in another trial they use frequent winner. I'm just mentioning
So
two, two
that's my next
strategies,
question.
which both of them are based on within attribute comparisons.
That's my next
And
question,
they
actually.
are kind of opposite to each other because, yeah, in this type of choices, they will tend to get opposite results. Um, but
But
I mean,
could it be that people just see the variance between the attributes? This gives them like the state in which they are, and then they think, is this the state? Is this the environment in which take the best is good or not, and then decide according to?
Yeah. So must it be a fixed strategy that people use throughout the 200 trials? This is the main question, maybe.
well, I mean, that's a difficult question to ask, right? Because usually you decide a strategy based on, let's say, a block of trials, and you need a large enough N in order to make a classification. But then if you will not be able to decide about a strategy for a single trial. It's very difficult.
Yes, but
Unless
maybe
you have some, I mean, yes, perhaps you can using eye tracking or something like that. Maybe using eye tracking, you might be able to see something in a single trial level. But if we need to do some classification based on choices, we need to aggregate. Now, you can do something like that. You say a subject, a participant comes to the experiment, it has a block of trial, and then I divide it into subblocks. And then I do a classification for each subblock and I see if it's consistent. When
right.
we do this, we typically find it's quite consistent. So, I mean, I would say it a bit differently. Let's say that we classify participants for the 3 attribute block, for the 4 attribute block, and for the 5 attribute block. Those are different blocks of trials, and they change in complexity. And usually, most of the participants are consistent. If they take the best in 3, they will also use it in 4 and in 5. It's not perfect. I mean, there will be few participants who will switch usually when you get to more complex decisions, as you might expect, there will be more who use take the best. But that's not very large number. Most of them, they are consistent. They seem to rely, if they rely on take the best on one block, they seem to rely on take the best in the next block. And I think it will be, I mean, if do you have an intuition that people will, I think people try to do something easy. They will not each time for every trial start to come up with a new strategy.
But you
They
just
might,
gave a
they
perfect
might,
example,
what?
right, Mari? You just gave a perfect example. So what happened if I have a weight of 9 and 2 and 1, which is very different from 3, 2, 1.
Yeah,
So I
yes,
see
but
this
you
state,
see,
and then I say,
the
I
weights
will
are,
go for take the best.
but our weights are fixed, right? Our weights are fixed. So all our trials are exactly the same weights. So I agree that if you have weights which are very different, that could generate a strategy change. But for a given weight distribution, which we choose it to be distinctive but not excessive, so they are more or less similar still. I mean, I think that the person will not start each time, oh no, now let's choose by a different criterion. You go into a mode and you just try to finish the experiment.
Yeah, okay. So I think we have to stop for now because we're after time. So let me just stop the recording and we can continue the discussion.